This video illustrates the use of IGW to create a Google Maps-based, one-click data-enabled model in China. Google Maps is used to zoom and pan to the area to be modeled, and the user selects and draws a box in the area of interest. In one click, the box drawn in the GIS environment is converted to a model in the IGW environment. Since this model is for China, the only existing dataset that can be used for the model is the DEM, which defines the topography. All other parameters, such as the hydraulic conductivity of the model area, the aquifer's bottom elevation, and the recharge rate, are assumed to be constant and are assigned by the user. The model is discretized and run to show the hydraulic head contours and flow directions. The model results are also plotted in a cross-section view. The model created here is a preliminary model that can be approved upon by the user with additional data. The steps to create the model are as follows. 1. In the Google Map interface, enter Chengdu, China in the search bar. A flag will appear in the Google Map display indicating the location of the city. 2. Increase the zoom level to 8 to focus the display to Chengdu. Adjust the zoom level until the appropriate map area is displayed for use in an IGW model. 3. When the area of interest is centered and completely contained within the display, click on the Capture GE Map icon to create a map for IGW. The user may choose from the 2 UTM coordinate grids available for China. Enter a 3 in the input box of the prompt that appears to use the 3-degree UTM zone rather than the 6-degree zone. Additionally, an appropriate projection system is suggested, although the user may import a system of their choice. Answer yes to the prompt to apply the suggested projection system and use the original map resolution. 4. The map will be automatically opened in the GIS Layer Explorer. Click on the Draw a Rectangle for IGW icon and draw a rectangle to define the modeling extent to be used in the IGW main window. 5. Click on the Extract Import Model Features from GIS to IGW icon, and the IGW main window appears with an Import Data window. Click OK to import the rectangle into IGW with the map layer as the model base map. 6. Select the domain polygon and edit its properties in Attributes Explorer. In the Flow Properties tab, check Conductivity and assign a constant value of 15 meters per day. In the Elevations tab, check Top Elevation and select Raster and ensure that DEM from IGW Server is selected. Check Bottom Elevation and enter a constant bottom aquifer elevation of 310 meters. In the Head Dependent Flux subtab, check One-Way Head Dependent Flux and select Top Elevation as the drain elevation. In the Prescribed Flux subtab, check Recharge and input a constant recharge of 10 cm per year across the model domain. Seven. Increase the model grid resolution and discretize the model. 8. Run the model and edit the velocity vectors in the display. Open the Velocity Draw option window and increase the grid separation between displayed velocity vectors. Also, ensure that the Seep Area box is checked. Note the easily discernible head contours and flow directions. Also note that the grid cells exhibiting seepage to the land surface are highlighted in blue. 9. Draw a cross-section through the center of the model and note the gradual decrease in hydraulic head from the northwest to the southeast, as shown in the Profiles display window. Check the Top Elevation box to display the land surface profile along the cross-section. Note the abrupt rise and fall of the land surface, which was visible in the Google Earth display seen earlier in this example.